All right, so Wednesday, we talked about how to find angles using trig. All right. Now, before we even get into anything, let's first, boys, let's first review SOHCAHTOA. All right, because again, we're going to be using that pretty much exclusively today. So remember, the SO part, that means sine of theta is equal to what? Sorry, this is on page 13. So sine of theta is what? What's the formula for sine of theta? Good. Opposite over hypotenuse. All right. Shh. Ka. All right. So that's cosine of theta. And it's what? A over H. What does that stand for? Adjacent over hypotenuse. And then the TOA part. So that's tangent of theta is equal to what? Opposite over adjacent. Good. Now, on the flip side, we had the inverse sine, cosine, and tangent. What did we use inverse sine for? Or inverse cosine? What did we use inverse trig ratios for? So that was the sine of -1, cosine of -1, tangent of -1. What did we use those for? To solve for what? This is what we did Wednesday. We used the inverse to solve for, what did we talk about on Wednesday? A lot? Guys, look back at your 6.3 notes. We use inverse trig to solve for what? Starts with an A. We used inverse trig to solve for something that starts with an A. Should be at the bottom of page 10. So we use it to solve for what? Angles. Good. So that means that if we take the inverse sine of opposite over hypotenuse, we get theta. If we take the inverse cosine of adjacent over hypotenuse, we get theta. If we take the inverse tangent of opposite over adjacent, we get theta. All right, so in other words, these are used to solve for angles. Today, we're going to actually focus more on finding sides. So before we do that, we're going to review what we did on Wednesday. So given the right angle shown below, set up a trigonometric ratio involving angle A and use it to find the measure of angle A to the nearest degree. So first off, here's angle A. We're going to call it theta. And remember, what's the first thing that I always tell you guys to do whenever you do any trig problem? What is always the first thing I told you guys to do? Right, label the sides, essentially. Okay, so in relation to A, which side's my opposite? CB. Which side's my hypotenuse? AC, which makes 17, or AB my adjacent. Now, the trig ratio that you want to use is based off of the positions of the given data, which are the side lengths. So look at what sides they specifically gave us. They gave us the adjacent and the hypotenuse. Thus, what's the only trig ratio that uses both the adjacent and hypotenuse? Cosine. So we're going to set up a cosine. So we're going to say cosine of theta is equal to what over what? Well, a over h, but what's the numbers? 17 over 22. And there's our equation. Now remember, in order to get theta by itself, how do I get rid of cosine? What undoes cosine? Not itself. Something close to itself, though. We kind of just went over it. The inverse cosine. Good. So we got to take the inverse cosine of both sides. Remember, inverse cosine undoes cosine, so that goes away. I'm left with theta is equal to the inverse cosine of 17 over 22. And remember, this part we can just put in our calculator. So if I go to my calculator, how do I get the inverse cosine to generate? So what button do I press to get the inverse cosine? So the cosine with the -1. Second, and then what? Cosine. So if you hit the second button first and then the cosine button, you get the inverse cosine. And we're just going to type in the ratio. So 17 divided by 22. So if I round to the nearest whole number, and if you did not get that answer, that means you probably have your calculator in the wrong mode. Make sure it's in degree mode. So what would that be, round to the nearest degree? 39 degrees. So theta is approximately 39 degrees. So that's what angle A is, 39 degrees. So that was review. Now, if we have two sides of any right triangle, then either of the acute angles can be found using the inverse trigonometric ratios, as long as we have two sides of the right triangle. But more importantly, if we have a measured and acute angle and any one of the sides, then any of the other sides can be found as well. And that's what we're going to be exclusively talking today, how to find missing sides. So, first off, let's talk some shop. Because solving equations like this is going to be helpful with solving the using trig for solving sides. So for A, how do I solve for x? So if you see like a fraction like this, what's kind of your gut instinct to do? It's one of your favorite things to do. Cross multiply. So I'm going to put the 5 over 1. I'm going to cross multiply. So I have x is equal to 5 times 6. So x is equal to what? 30. Okay, can do the same thing over here. Cross multiply, boys. Cross multiply, and then you'll end up dividing.
Sorry, my ear's not listening really well.
So 3x is equal to 18. So how do I solve for x? Yes, divide by 3. So x is equal to what? 6. What about for this one? So we're still solving for x. I'm going to put the b over 1. So x is equal to b times a. So we can't do anything else with that. So x is equal to ba. Walk me through this last one. What do I do? Okay, so I got is equal to a. I'm still solving for x. So how do I get rid of the b? What operation is being done to it? You divide by the b. That goes away. X is equal to a over b. Boys, come on.
Dude, you threw it at me and then I slapped it out of my face. Like, what the frick, dude?
All right. Now, why is this important? Like, this is typically what these equations are going to look like, but we're going to throw a trig in them. All right. And again, once you do the cross multiplication, from there, it's either you're dividing something over or you're multiplying something together. So in other words, it's going in your calculator. All right. Now, so using this diagram, we're going to solve for the different sides here, given this reference angle, 36. So before we do anything, we got to do what? We got to do what before we do anything? Label the sides. So which side? So someone besides Rajan or Owen, which side is the opposite of 36? So if you make your eyeball, what side's it staring at? PM.
So now I'm knowing.
What's the opposite? Sorry, what's the hypotenuse?
Oh, wait. Am I wrong?
I'm looking at the right problem.
Oh, what's the problem I listened to?
Exercise 3, page 13. What's
okay,
hypo-
the right problem. Wrong problem.
What's the hypotenuse? PN, which makes MN my adjacent. Now, it wants us to solve for the length of MP. So that's the hypotenuse. So that's X.
And what's the situation with it? Just the hypotenuse would be,
Hypotenuse is always right across from the 90.
I know, but what situation would it be P?
It wouldn't. It's hypotenuse is 2 letters. PM.
That makes more sense.
Side length is always 2 letters. All right, so now since we're solving for PM, that means I'm using these 2 sides, the side they gave me and the side I'm trying to find. So based off of what's labeled and the position of those sides, which trig ratio do I need to use? So look at which sides are with the highlighted stuff. And then look at which trig ratio uses those 2 sides. So which trig ratio do I use? Cosine. Good. So I have cosine of what? What's the angle measure? 36. I have cosine of 36 is equal to what? Guys, please stop talking. 28 over x. Now, to solve, I'm going to do just like what we did with the ones in exercise 2. I'm going to put cosine of 36 over 1, and we're going to cross multiply. So I got x cosine of 36 is equal to 28. Now remember, cosine of 36 is just a number. We know that because of your trig ratios and your trig table. So how do I get the x by itself? What did I do up here if I had a number being multiplied to x and I need to get rid of it? We divide by it. So I'm going to divide both sides by cosine of 36. So x is equal to 28 over cosine of 36. And guess what? This can go right into the calculator. And you're going to round to the nearest tenth. So let's put that in our calculator. So I'm going to do 28 divided by, hit the cosine key, not second cosine, just cosine, of 36. Make sure you close that parenthesis. All right, does everyone have that in your calculator? So everyone should be putting these in this calculator practice. Hit enter. So to the nearest tenth, how long is the hypotenuse? So 1 decimal place. 34.6. So x is approximately 34.6. So that's what this is. Now, they then want us to solve for Pn, or the other side. So we're going to call that one y. Now, what I tell students is always use the side you're trying to find with the side they gave you. Even though we already found the other side of the triangle, we want to use the side that they originally gave us because that's going to make our answer the most accurate. So based off of what's highlighted in green and what sides are associated with them, which trig ratio make the most sense to use? Tangent. So I have tangent of 36 is equal to what? How do I set up the ratio? Not 28 over y, it's y over 28, opposite over adjacent. All right, so I'm going to put this over 1, and then I'm going to do what? Cross multiply. So I have 28 times tangent of 36 is equal to y. Now, since the y is already by itself, I just got to put this in my calculator. So you can literally type that in your calculator as you see it. So this would be 28 tangent of 36. Make sure you close the parenthesis. So if you put the 28 and then tangent right after it, it'll automatically read as multiplication. If it makes you feel better, you can put the multiplication sign in between the two, but it doesn't really matter. All right? So everyone got that in your calculator? What do you get to the nearest tenth? 20.3. So y is approximately 20.3 units. So this is 20.3. And just like that, we use trig to solve for all the sides. Now, if let's say the solving by hand confuses you guys. How could you use your trig table? Couldn't we figure out already what the tangent of 36 is? All right. So what is the tangent of 36? If you look at your trig table, what's tangent of 36? So let's say I set it up again. So tangent of 36 is equal to y over 28. What is the tangent of 36?
0.7265.
0.7265 is equal to y over 28. And then you can cross multiply that way. So if the whole cosine of 36 messes you up, just use your trig table. Okay, and replace that tangent of 36 with your trig table. All right, and what's 28 times 0.765? So if we do 28 times what was it, 7.265, was it?
7.7625.
Okay, I had it backwards. We still get pretty darn close to what we need. All right. So this one appears more exact, but using the trig table and putting this in, as long as your answer is within ballpark, like within a couple of decimal places, I'm fine with that. Okay, so whichever way makes the most sense to you, that's fine. All right, so that was just the other way. So this was like if we used our trig table first. But we're still going to practice doing it with the calculator. So here's kind of the key steps for solving for a missing side of a right triangle. First, you absolutely need to know what one side is and what one acute angle is. If you don't, you can't solve. We're going to set up the trig proportion using the angle and sides. And the way we pick the trig is based off of the position of the given sides. So for example, if they gave us the adjacent and we need to find the hypotenuse, we use cosine. If they gave us the opposite and we need to find the adjacent, we're using tangent. All right. If they gave us the opposite and we need to find the hypotenuse, we use sine. All right. And then we solve the proportion for the missing side. And again, that's just cross multiplying. So let's look at this one. So my reference angle's right here. This is 24. So before I do anything solving wise, we're going to do what? We're going to label the sides. So which side is my hypotenuse? What side's my hypotenuse? AC is. What side's my opposite? So where's the eye staring? AB. Which makes BC, by process of elimination, my adjacent. So remember what I said, if you can identify the opposite and hypotenuse, adjacent is just whichever one's left over. Because in my opinion, I think for most students, adjacent is the hardest one to identify right off the bat. Now, they want us to solve for BC. So BC is right here. We're going to call it X. So look at the sides that we were given and the side that we're trying to find. And look at what we labeled them as. Which trig ratio would be the most efficient one to use based off of what we were given and what we're trying to find? So which trig ratio should we use based off of the side we were given and what we're trying to find? Cosine. We were given the hypotenuse, which is 18, and we're given the adjacent, and we're trying to find the adjacent, which is X. So since cosine is the only one that uses adjacent hypotenuse, we have to use cosine. So I have cosine of what? 24 is equal to what? X over 18. So then I'm going to stick that cosine of 24 over 1 and do what? Cross multiply. So I have X, because 1 times anything is just itself, is equal to 18 times cosine of 24. Then what's the last thing I got to do? Just put this into my calculator. So go ahead and put that in your calculator and round to the nearest tenth, so 1 decimal place. So X is approximately what? It's what? 16.4? Good. And it's not degrees because it's not a angle measure, it's just the side length. All right. All right, exercise 5 is a little bit different, so let's talk about it. We have an isosceles triangle, not a right triangle, an isosceles triangle that has a base of 26 inches and the base angles that measure 64. So this one's a little funky, but let me show you. So we have an isosceles triangle. It's not right. So these sides are congruent. And they said the base is 26 inches. Remember, the base is the non-congruent side. So this is 26 inches. And it says the base angles is 64. So that means that these two congruent angles are both 64. Now, it wants us to find the height of the isosceles triangle to the nearest 10. So in other words, if I drew a line straight from the tip of the isosceles triangle to its base, first off, what would that make the isosceles triangle into? It makes it into two what? Right triangles. So these angles will be right. It also does what to the base? It splits in half. So that means that this little piece is 13 inches. This little piece is 13 inches. And it wants us to solve for the height. And again, the height's going to be that green line. So we're going to call X. Well, don't we have enough information to find that height now, since we have a right triangle and a given angle and another side given to us? Yes. So we're going to focus specifically on what I just highlighted in yellow, that triangle. All right. So first off, we're going to label the sides of that triangle with 64 in mind. So what side is X? It's the opposite. What side is this side? Hypotenuse. And what side's the 13? Adjacent. So based off of where the position of the side we're given and the side we're trying to find and what they're labeled as, which trig ratio should I use? So here's what we're trying to find. Here's what we were given. So which trig ratio should I use? Tangent. Good. We were given the opposite and the adjacent, so we're using tangent. So tangent of 64 is equal to what? How do I write the ratio? X over 13. And then it's just business as usual. Put this over 1. Cross multiply. X is equal to 13 tangent of 64. And all we got to do is do what at this point? Put it in our calculator. So once we put that in our calculator, X is approximately what? It's what? 26.7. Good. So the height is approximately 26.7. Now, it then wants us to find one of the legs of the isosceles triangle. Remember, the legs are the congruent sides. So in other words, we need to find this side right here. So let's call that one Y. So now, again, using what we were initially given, which is the 13, and what we're trying to find, which trig ratio should I use? Cosine. Good job. So I got cosine of 64 is equal to what over what? 13 over y, adjacent over hypotenuse. All right. So put this over 1, cross multiply. I got y cosine of 64 is equal to 13. How do I get the y by itself? Nope. We just got to divide by cosine 64. Remember, cosine 64 is a number. So we divide by cosine of 64 on both sides. So y is equal to 13 over cosine of 64. And we just got to put that in our calculator. So go ahead and do 13 divided by cosine of 64. Tell me what you get. Not times divided. It's what? 29.7. Okay, I thought you said 25. I was like, there's no way. All right. So yes, it is 29.7. I don't know why I put 0.5. Clearly said 7. So guys, that one you just had to know what an isosceles triangle is. But just know that just because they give you a non-right triangle doesn't mean you can't make a right triangle within it. But remember, trig stuff, at least the stuff that we're learning, only works for right triangles. All right, last one. So in the right triangle PQR, so we have a right triangle PQR. Angle Q is the right angle. Angle R is 48 degrees. PQ is 11. And they want to know which expression correctly calculates the length, the length of PR. All right, so first off, what do I always tell you if you don't have a picture? What are you supposed to do? Draw it. So I have some right triangle. And it's PQR where Q is the right angle. So you got to make sure Q ends up here. So then you can put P and R on either of the other spots. You could have flip-flopped the P and R, but the Q had to be the right angle. And they said that R is 48 degrees, so right here. They also said PQ is 11. And they want us to find PR, so we're going to call that X. Now, before we do anything, we're going to label our sides. So what do I got? So walk me through which sides I'm labeling. What's opposite? What's hypotenuse? What's adjacent? PQ's opposite. Good. What else? Which one's hypotenuse? RP, which leaves RQ as the adjacent. So based off of our sides labeled and our sides given, what trig function am I using? Sine. Right your name on the board, I got someone out. Right, because we're given the opposite and the hypotenuse. So we got to use sine. So I have sine of 48 is equal to what? 11 over x. Good. Now, this, we don't even really have to do anything because look at our multiple choice. Which is the only one that would make sense? 1, because that's the only one with sine in them. Automatically, that eliminates it. But if we want to check, put this over 1, we get x sine of 48 is equal to 11. Still would have to divide by sine of 48. So x is equal to 11 over sine of 48. That's all we needed. Okay, so now you should be able to do, so that delta math that I signed yesterday when I was out, you should be able to do like those last 5 problems pretty easily now. All right, that was that last section. But your homework for over the weekend, which I will be checking on Monday, I'll check the one from yesterday as well, is pages 15 and 16. Nope, just 15 and 16. 15 and 16, yes. You guys got a solid 10 minutes. You could probably knock out a little bit. Oh, also, guys, the journal keys aren't posted yet, but I'll have them posted by this afternoon. I just haven't had a chance to do them.